On problem 4 in exam 1, there are two spheres inside a hollow sphere. And you're told that sphere A has 4 coulombs of charge on it, which I'll represent as 4 pluses, and sphere B has 2 coulombs of charge, which I will represent as 2 pluses. And that the outer wall of this hollow sphere has a total charge on it of minus 4 coulombs, represented by these 4 minuses. In order for this to be a stable charged configuration, there has to be charge on the inner wall of the outer sphere, and that charge is going to have to be minus 6 coulombs. So let me put that 6 coulombs in like this. So we have electric flux density lines going from the positive to the negative charges on the inside. So at this point we have minus 6 coulombs on the inner wall of the hollow sphere. So now we're going to move sphere A until it touches the inner wall of this hollow sphere. So as we move sphere A towards the wall, we have this coulombic attraction between the positive charges on the sphere and these negative charges on this inner wall. So those negative charges are going to be attracted towards the sphere. So although these negative charges are repelling each other, they're also being attracted by these positive charges. So the closer sphere A gets to this inner wall, the closer the negative charges and the positive charges will get. So here's the instant just before they touch. So when they touch, these conducting electrons can flow onto sphere A, neutralizing it, so it will have no net charge. And at that point, we'll have the following. So now if we move sphere A away, A will have no net charge. And minus 4 coulombs have been removed from the inner wall of this hollow sphere, leaving only a minus 2 coulombs. And nothing has changed on the outer wall of our hollow sphere. It still retains minus 4 coulombs, because what was going on inside here is completely isolated electrically from the outer wall of this hollow sphere.